In this lesson, we're going to discuss power management in the data center. A critical part of protecting the network infrastructure you service is managing the electrical power that's supplied to the network devices and computer systems on your network. This requires knowing when to use different power devices, including surge protectors, line conditioners, redundant circuits, redundant power supplies, and dual power supplies. First, let's talk about circuits. When you implement network equipment in a data center, you need to ensure that there's sufficient power supplied to the room. Specifically, you need to make sure that the server room has sufficient amps per circuit to support the network's devices within the room. It's important that you remember that an AC circuit's electrical load shouldn't exceed 80% of the circuit breaker's capacity. To determine the electrical load on a circuit, divide the wattage of each electrical device by the number of volts available in the circuit. This equals the amps the circuit requires. For example, suppose you have three 500-watt servers running in the data center, and they're all connected to the same 20-amp AC power circuit. To calculate the load of a single server, divide 500 watts by 120 volts, which gives you a result of about 4.1 amps. Because there are three servers, you must multiply this result by 3, which tells us that the total load required by these devices is 12.3 amps. With just 3 servers connected to the same 20-amp AC circuit, we're consuming about 62% of the circuit's capacity. As you can see, it takes a lot of electrical power to support a data center. Most large organizations understand this and build adequate electrical power availability into the building's infrastructure. However, you need to be very careful when implementing a data center within a small business. Frequently, small businesses may simply allocate an available office or closet to function as the data center. Because these rooms weren't designed to function as data centers, they typically only have a single 15-amp AC circuit installed. In fact, it's not uncommon for several rooms to share the same 15-amp AC circuit, leaving the small business data center way underpowered. If this is the case, you may need to hire an electrical contractor to install a dedicated circuit for just the equipment in the data center. Also, be aware that in dedicated data centers, a cable tray system is commonly used for power distribution instead of a traditional conduit. Cable trays are useful because they allow new circuits to be added as needed or existing circuits to be reconfigured without having to pull cable through wall conduit, which can be very difficult. With this in mind, let's now look at protecting electrical power. A disruption in the power supply can adversely affect the availability of computer systems and devices in your network infrastructure. You should be familiar with the following conditions that could affect the electrical power supplied to your data center. A surge or spike is a sudden rise in voltage. This could be caused by a lightning strike, a power plant coming online or going offline, or malfunctioning electrical distribution equipment. A sag or dip is a reduction in voltage for a short period of time, up to several seconds. This could be caused by overloaded, daisy chain power strips, faulty wiring, sudden power draws, such as when equipment is first turned on, and a large equipment that draws a lot of power, such as an electric motor. A brownout is a reduction in voltage that lasts longer than a few seconds. A brownout can usually be traced back to your utility company during times of high power demand. Typically, a brownout occurs when there's more customer demand for electricity than your power company can meet. A blackout is a complete power failure. A blackout can have a variety of causes, such as a down power line or failed transformers. A fault is a momentary power outage that can be caused by a variety of factors. A transient is power fluctuation caused by line noise or disturbance. All these power issues can cause serious problems in the data center. If a power loss occurs, your system shut down and you risk losing valuable data. Remember, for most organizations, the most valuable asset isn't necessarily their buildings or furnishings. It's the data that they create and store. Our world runs on information, so you need to protect yours at all costs. There are several things you can do to protect the power that's supplied to your network infrastructure. You can use a surge protector to keep equipment safe from power spikes. Before you purchase a power strip, make sure it has a built-in surge protector. A line conditioner is a device that delivers voltage at the proper level so equipment can function properly. A line conditioner improves power quality by removing noise caused by electromagnetic interference, EMI, and radio frequency interference, RFI. It also provides small amounts of additional power to protect against power dips and surges. Now, just like all critical hardware, circuits must be redundant to support critical services. You need at least 2 complete circuits so that if one goes down, The other can support your network. You can have 5 or 6 redundant power supplies, but if your circuit fails and you don't have a backup circuit, they won't do you any good. Redundant circuits are as important as redundant power. For critical systems such as servers, switches, and routers, you should implement redundant power supplies. The power supplies within these systems convert AC power from the wall outlet to DC power that the device can use. Over time, power supplies degrade and eventually fail. If this happens to a critical system, it will go offline and you risk network downtime and possible data corruption. By implementing a redundant power supply, you make sure the failure of one power supply doesn't bring your system down. The second redundant power supply can keep it going until you can replace the failed power supply. To protect against blackouts and brownouts, you should implement an uninterruptible power supply, or a UPS. A UPS provides immediate backup power that protects against temporary power losses. A UPS system converts AC power from the wall outlet to DC power that's stored in a large battery. You plug the UPS into the wall outlet, and then you plug your network devices and computer systems into protected outlets on the UPS. When the power supplied by the wall outlet falls below a certain voltage level, usually about 80 volts AC, the UPS automatically switches its protected outlets from the wall power to battery backup power. This allows the system plugged into the protected outlets to continue running as long as the battery lasts. When you select a UPS, keep in mind that not all UPS units are created equal. Some can provide backup electrical power much longer than others. If data protection is critical, don't skimp and purchase a cheap UPS. Purchase one with more battery runtime than you think you'll need. Plan for capacity. The battery runtime ratings advertised by UPS manufacturers are based on a single protected system. If you connected 2 systems to that same UPS, your total battery protection time is cut in half. If you connect a third system, your battery time is cut by 2/3. Most UPS systems include a surge protector, and some also provide a line conditioner. Cheap UPS units don't provide an automatic shutdown feature for connected computer systems. When the battery is drained, the computer loses power and shuts off uncleanly. This can cause data corruption. A more expensive UPS unit includes a serial or USB cable that connects to the computer. When the battery is nearly drained, the UPS sends a shutdown signal to the computer through the cable, allowing it to shut down cleanly before the battery is exhausted. Online UPS units provide power to protected devices directly from the UPS battery all the time, even when the wall outlet is providing sufficient voltage to run the system. The UPS continually recharges the battery, which in turn continually supplies power to its protected system. Because of this, online UPS units provide the best performance, as there's no switchover delay when the power from the wall outlet goes offline. The protected system continues to run off the UPS battery as it always has. However, the UPS battery tends to deteriorate quickly, so you have to replace it frequently. Online UPS units are also more expensive than offline UPS units. Offline UPS units also use a battery for backup power that's continuously charged. Offline UPS units are typically more affordable than online UPS units. However, as long as the wall outlet power remains above the voltage threshold, the UPS provides the protected system with AC power directly from the wall outlet, not from the battery, like an online UPS. If the wall power fails for some reason, the UPS detects the voltage drop and immediately switches from the protected system from wall power to battery power, allowing the protected system to continue running. However, there's a momentary interruption in power, about 25 milliseconds, as the UPS switches from the wall power to battery power. Most systems can handle a power interruption this long and will stay running long enough for the switchover to occur. But a heavily stressed or failing power supply may not be able to handle it, and the system could go down. After you purchase a UPS, you need to continually monitor its battery. As with notebooks, tablets, and smartphones, the battery within a UPS slowly degrades over time, especially if it's heavily used. At some point, you will need to replace the batteries within each UPS. If you don't, then you'll have no protection when the wall outlet power fails. One of the problems with the UPS is the fact that it only provides temporary power protection. Depending on the quality of the UPS you buy, this could be as short as 10 minutes. If the power outage goes on longer than this, the protected system will go down when the battery is exhausted. To keep this from happening, consider using a redundant source of power. This provides your critical network systems with an alternate source of power should the power supplied by your utility company be offline for an extended time. For example, you can implement a backup generator that powers your entire data center if the main power is lost. redundant sources provide power for longer periods than a UPS. However, most backup generators typically take a few minutes to start up and come online. Therefore, you still need a UPS on your critical systems to keep them running until the backup generator is available. In addition, most generators run on gasoline, diesel fuel, or propane. If the power outage goes on for an extended time, or if the fuel distribution system is compromised, such as in a natural disaster, then you may exhaust your fuel supply and lose power again. Basically, your critical equipment draws power in this order. First, the UPS line conditioner, then the UPS battery, and then the backup generator. The last piece of equipment we'll discuss affects what type of power is supplied to your network. This device is called a dual power supply. Some circuits require the ability to absorb and release positively polarized electrical energy and negatively polarized electrical energy. These circuits require a dual power supply to function correctly. A dual power supply is a hardware unit that supplies positive polarity, negative polarity, and ground to the circuit, which allows it to release and absorb polarized energy as required. That's it for this lesson. We discussed power management in the data center. First, we discussed the different types of power outages and incidents you need to be aware of. Then we reviewed the different types of power protection equipment you should use in your data center, including redundant circuits, surge protectors, line conditioners, redundant power supplies, and dual power supplies.